these last several slides, what you're looking at, and the center of our galaxy is a black hole, and it's in the direction of the stars associated with the constellation Sagittarius. So we call that Sagittarius a star. And what they did, and I'm going to show you this animation, what they did to know that it's a black hole, in order to get a black hole, I think I did the other day where you have like a trash bag and you stomp it down. Okay? You're basically compacting, I think I said wrapping paper at Christmas time, compacting that wrapping paper closer and closer and closer together. And I know it sounds weird, but of course there's atoms that make up your wrapping paper. If you squish it enough, you're actually going to create a neutron star. That was weird. But if you squish that material even farther from a neutron star, which neutron star is like neutron soup, like instead of like protons, electrons, it's all neutrons because you squished it. Well, if you keep squishing it, you're going to create a black hole. So you can take anything. You could take that chair and make it into a black hole. Just had to squish it up. So the thing that makes a black hole is basically a certain amount of mass in a small area, because that's density. Area.
So so one of the questions of the homework, because it says describe the evidence indicating that a black hole may be at the center of our galaxy. So are you talking about what's in the black hole?
No, not what's in the black hole. And actually this is the evidence. So I'm going to animate this and we're going to see that these are the paths of, there's a black hole. I don't even know if it's one of these dots, but there's a black hole and each dot is like a star. And the star is going around this object that we can't see. I know it's shining. It's sort of shining on the crust outside, but after a certain point near the black hole, it is black.
Because I couldn't figure out, because I was trying to do it last night, and I was trying to figure out what you meant, and I didn't want to do it and then get the wrong answer.
So the evidence is the motion of stars.
Okay.
Motion of stars. So we said, well, how do we say this? Well, we kind of know that, even with regard to our sun, the way the planets orbit the sun is kind of a function of what the mass of the sun is and how far the planet is from the sun. So if our planet was more massive, if our sun was more massive, our planets would go faster, just because that's the way gravity works.
Okay.
So with that in mind, if we look at this, this would be, wavelength and the radio. This is radio energies. Okay. So Sagittarius A star is the black hole. There's an X-rays. Okay. And this is taken from radio. Again, and this is kind of maybe what you said, if it's a black hole, why is it so bright? So think of it this way. If this is, and I'm not sure this is, but maybe it is trying to show you the center of Sagittarius A star. Think of basically that is the energy that's just outside the black hole. Because we call it an event horizon. If it's on the inside of the black hole or inside this thing we call the event horizon, then we're not going to see it at all. And that's just kind of showing you the same as we looked at. So 16 years to kind of plot what those stars are doing, again, so you can get to a mass, and then know that it's a small area, so you know it's squished down enough to be a black hole. All right, so we'll keep plugging away. Next part is this one. It's just pretty pictures, basically. And I do have a handout for this one too.
Thanks.
To me, one of the things we've talked about in here is there other life out there? You guys think there would be other life out there? I think there is. I think there could be. So, because this topic of the concept of a galaxy, we're only one galaxy, the Milky Way galaxy. We're awesome, but we have a lot of stars, and most of those stars are planets. But there's so many different galaxies too. You're like, really? So the thing about galaxies is sometimes we can see them, this is face on, but sometimes we see them like edge on, they look like a line. Okay, so this is a face on galaxy. It's also a spiral galaxy like the Milky Way. It's called the fireworks galaxy. So they get fancy names depending upon what they kind of look like. It's just beautiful.
That's just crazy how they look like that though.
Mhm.
You think it would just be a big cluster of
Right.
spirals, but it's not. It's
They-
a big, like it's a spiral.
It is a spiral and it's like a plane. So if you look like, you know, you could like turn it this way and it would like a line.
Yeah.
Uh-huh. Now we're going to talk about the different types of galaxies, but it's not even the most common galaxy, spiral galaxies, but it's a popular one. This is Andromeda. I'm going to play this little video, but Andromeda has 2 galaxies near it. I don't know if you can see this one and this one. So Andromeda, I think, is a little bigger than the Milky Way galaxy. And they're kind of like little gnats buzzing around a horse or something, horseflies. And we talked the other day with our galaxy, we have something called, I think Sagittarius dwarf galaxy. There's another galaxy, a dwarf galaxy, that's actually passing through the Milky Way, and it's losing itself. So let's take a look. I think this is 3 minutes too. Is Hubble, of course, the Hubble Space Telescope, named after Edwin Hubble. And what Hubble did was to go ahead and kind of categorize galaxies. And so the categories I talked about in the previous slide, we have spirals, and we have ellipticals, and we have irregular galaxies, but we also have barred spirals. And as it turns out, the Milky Way galaxy is not just a plain old spiral, it's a barred spiral. And the type of galaxy has these capital letters that goes with it, as is spirals, as E barred spirals, E ellipticals, and I are irregulars. So they call it a tuning fork diagram. So I don't know if you've ever played around with this. They're metal and they have like a handle and they have like prongs and you hit it, go ding. I could have brought one. I have one in the lab, but it makes sound, the tuning fork. So this would be the part you hold it. And up here are figures of kind of what these galaxies look like. So you might recognize up here we have spiral galaxies. This one is kind of like the picture that we saw a little bit ago, kind of the face-on, beautiful spirals. But what happens is we have an assortment of spiral galaxies. We have kind of the wide open, beautiful ones, but we kind of have, and if this is the black hole, the center of the galaxy, these are my arms, this would be what we call a spiral galaxy C. I can't do this. Okay, and then if it's B, it's like this, and if it's A, it's like this. So the difference between C, B, and A is basically how tightly wound the arms are. So, and then the difference between this, so the Milky Way is one of these, a barred spiral. And the only difference is can you see it's got like a major, let's pick on this one because it's easier to see the arms. But there's a bar that kind of stars that kind of connect one of the major arms. So here we have the C is wide open, the B is tighter, and the A is tighter yet. So we have those spirals and barred spirals. And irregulars aren't on here, but I think they kind of come right here. And then we have ellipticals, and ellipticals, I think you might have mentioned, Jordy, it seems like the galaxies should be kind of like a globular cluster. But yeah. And actually, the ellipticals are kind of like that. They don't have a plane. They're kind of like a ball. Yep. They're older galaxies. So those are a popular galaxy. Okay. So with regard to these ball ones, these ellipticals, we use the letter E to designate ellipticals. And then we have an assortment of possibilities. If they're nice and round, we call them E0s. And the 0 is what we call its eccentricity. The more oval they become, you can kind of see this, they become more oval for 3, 5 to 7. Then actually we call them ellipticals 3, 5, and 7. But it kind of depends on how you're seeing it, like if you're seeing it, what your angle is. So that's something they have to take into consideration. So this is another galaxy, looking at it face on. And you can kind of see some similarities with regard to the Milky Way galaxy. It has a disk portion, it has major spiral arms, We talked about the Milky Way. Our galaxy has a halo region that has a lot of dark matter. So this is face on and this is edge on. For me, we kind of like the face on instead of the edge on. But can you kind of see where the edge on has, you can see the center of the galaxy is there. That's the nuclear bulge. That's where the black hole is. So we just can't see it face on, it's edge on. And we can actually get a sense for whether it's your spiral galaxy A, B, or C, because the more tightly wound it is, the thicker that bulge. So we can actually still kind of categorize it. Unbarred spiral galaxies. And here's this one's a barred spiral galaxy. So hopefully you can kind of see the difference. They're both face on and just gorgeous. Wish I could take pictures like that. But here's the barred spiral. Barred spiral. This is a regular spiral, pinwheel galaxy. And this is an elliptical galaxy. So you can kind of see it's just, and you're like, it almost looks like a globular cluster. And it does almost look like a globular cluster, but it's much farther away. So these are elliptical galaxies. So what's up with elliptical galaxies? They're relatively old stars, and they don't have much juice left in them to create new stars. Elliptical galaxies, they can have a lot of stars in them. We call those giant elliptical galaxies or dwarf elliptical galaxies. So to me, I mentioned globular clusters. This totally looks like a globular cluster, but it is actually an elliptical galaxy. So this would be a dwarf elliptical galaxy, and these are normal elliptical galaxies. Dwarf elliptical galaxy, just a bunch of cool pictures. But try to kind of put things in perspective. Whenever you're looking at a galaxy, that has to be far away from our galaxy. And the reason it looks kind of fuzzy is it's got a bunch of stars that look so they're far away. So there's Hubble tuning fork diagram again, where here's our ellipticals, here's our spirals, here's our barred spirals. Again, the different types of spirals, C, B, and A, how tightly wound the arms are. That might be a test question when I'm looking for test questions. This is an example of an irregular galaxy, sometimes called lenticular galaxies. I guess it's different than irregular galaxies. But lenticulars, not irregular, are kind of like this crossover area on the Hubble tuning fork diagram of galaxies. Gorgeous road trip, right? I think I might have told you guys before, on my bucket list is to go to the southern hemisphere. So in the southern hemisphere, they can't see Andromeda Galaxy, but they can see these other galaxies, and they're the small Magellanic Cloud and the large Magellanic Cloud. So naked eye, that's pretty cool. Again, the small Magellanic Cloud, the large Magellanic Cloud in the southern hemisphere. Cool telescopes. These, what's that?
Huge.
What's huge? The telescopes? They are. And they aren't the ones that they get pretty pictures, but they, because they're like radio telescopes, I think. So they are huge. This kind of goes back to Hubble Space Telescope, and again, the lights that you're seeing are not stars, they're galaxies. Cool. Well, we're going to take a look at one more part. For this subject, I kind of like the dark skies. I kind of like the lights dim. All right. So here's the last one we're going to do today. This ran out. I'll just give you 30. Take one down. So, if I had for this subject, if I had a bunch of plates, or I could bring in my plates, each plate represents a galaxy. We're going to kind of talk about how those galaxies are kind of organized. So, actually, it's okay with you. I have a poster I wanted to bring, so we'll go ahead and quit there for the day. And I'm going to start here on Monday and bring in my poster.
Yeah, 4 questions are due like they were last time?
Yeah.
Waiting for the test, okay.
Yep, same pattern. You got it. And the test is on the 10th. Did you get that? December 10th.
Test,
Yes.
the chapter 4, or the unit 4 test is on the 10th, and then that next Monday is final exam.
Okay, so the 10th and then the
17th.
17th.
Yep.
Thank you, Doherty.
Thank you.